as the sudden kind of, quiet starts across the room. So first of all, I'd just like to welcome everybody here this evening. My name is Professor Juliana Earley. I'm the Head of Mechanical and Aerospace Engineering here at Queen's University Belfast, and I'm really honoured to welcome all of our guests here this evening for our 20th Annual Sir Bernard Crossland Lecture. I'd like to offer a particularly warm welcome to our special guest this evening, Dr. Iain Percy for Artemis Technologies, who will be delivering the lecture today. We're hosted here this evening once again by the Chief Executives Club at Queen's and Engineers Ireland in association with the Institution for Engineering and Technology. I'd like to thank our established event partners, Engineers Ireland, in particular the current President, Orla Feely, and Jared Bruger, who are joining us this evening. We're also extremely appreciative of the links that we have with the Institution for Engineering and Technology, their support in delivering this lecture, and in particular their support in delivering the unplugged session with our students this afternoon, which I believe was highly successful, delivered by Iain, and some interesting conversations and questions from what I'm understanding from the conversation outside. So this lecture, or this annual lecture, is named in honour of our late colleague, Sir Bernard Crossland. He was a man of great passion, he had a huge commitment to the engineering profession, and he really did make a lifelong contribution which has stayed with many people in this room to this date, improving both the engineering profession and society at large, and I think is an inspiration for a lot of people as they progress in their careers in engineering today. He's certainly been an inspiration for me. These lectures go back to 2001, so we're 20 years on from the first one today, and they came from a steer with Sir Bernard himself. So it's really a lasting legacy that we're seeing here today, that these lectures persist to this audience sitting in this room today. He never fully retired. He was one of those people who always had to be active and always had to be engaged. And he was an active member of the committee and part of the organisation of the first 11 of these lectures until he unfortunately passed away in 2011, which I think was a very sad day for everybody who had worked with him. The small organising committee that he worked on with these lectures is delighted to carry on this prestigious lecture, which is obviously named after him. And I want to particularly offer my thanks to Jonathan, who has continued to steer that committee as the chair of the Sir Bernard Crossland Lecture Organising Committee, and the rest of the committee members who have continued to serve and support the organisation of this lecture annually, and hopefully will continue to do so going forward. So again, I'd just like to offer you our thanks on behalf of Queen's. In terms of this lecture and the beginning of this lecture, they've played a vital role in developing closer links between Queen's University, our local businesses, stimulating links with industry, enterprise and the economic sector here in Northern Ireland and further afield. As an institution, we are incredibly proud of the continuing economic impact that Queen's has on our local economy. In terms of just a basic estimate, at the moment, it's estimated that Queen's, in terms of our activity, has an estimated £1.9 billion impact on the UK economy with a cost-benefit ratio of more than 6:1. We're incredibly proud of our role as a civic university, where we're working across a range of local community activities, where we're co-creating events which make positive differences in our local communities, and addressing large-scale societal benefit issues like COVID-19 research which is feeding into addressing some of our Brexit issues, addressing research problems which are having real societal impact. We're also playing a leading role in the innovation pillar of the Belfast Regional City Deal, a deal that will exist, secure jobs in our current economy, and create thousands of new, highly skilled opportunities in what is a vastly growing knowledge economy, representing over £220 million worth of investment in advanced manufacturing, healthcare research, data science and creative industries. We're really seeing that we're at the forefront of really driving forward our economy today. Queen's is continuing to be a driver of economic and social change, and it's initiatives like this Sir Bernard Crossland lecture that allows us to highlight those continuing successes and our role within our local economy. I'd now like to say something about the main event, which is obviously our guest speaker this evening, Dr. Iain Percy. As many of you will know, Iain is a 4-time Olympian, a 3-time Olympic medalist, and a double Olympic champion. For the vast majority of people in this room, that will be enough, and they would have retired at that point. But instead, he is also a veteran of 4 America's Cup challenges, and then went on to join Artemis Racing as a tactician, further appointed as the team manager in October 2013. Again, for the majority of us, that would be enough for a lifetime. But because of his passion for the ocean and trying to drive forward the decarbonisation agenda, he founded Artemis Technologies in 2017 with the mission to show how the technologies that have been developed through the America's Cup could be used to decarbonise the maritime industry at large. Utilising world-class skills in simulation technologies, the development of new lightweighting technologies, electronics, hydronics, aerodynamics, hydrodynamics, and everything else you can possibly think of, they really have been at the forefront of driving forward new technologies and really trailblazing in their sector. Here at Queen's, we are delighted to be working closely with Artemis Technologies and a number of people who are in this room through projects such as the UK Research and Innovation funded Strength in Places, the recently funded Northern Ireland Green Seas programmes, which are allowing us to build on our rich engineering history here in Belfast and to really position ourselves as global leaders in zero-emission maritime technologies. It's truly an honour to have you here with us this evening, Iain, for our 20th annual Sir Bernard Crossland lecture. So without further ado, I'd just like you all to please join me in welcoming Iain as he comes to deliver his lecture this evening on Race for the Seas. Thank you, Iain.
For you again. I should credit the Conservation International for that video, but I thought that Han Solo would do a much better intro than I ever would into the power of the ocean. But the ocean is something I very much do care about, and has been a passion through my whole life. As you very kindly introduced me there, Juliana, I have had a varied career, if you'd call it that. But the thread through most of it has been the sea, and I think that's something that's always been incredibly important to me for many reasons. I started sailing about the age of 6, and I can still remember clearly to this day, first being free on the water, first being in control of a boat on my own, being able to go anywhere. And it was that last bit that always stuck with me, being able to go anywhere. You know, I probably couldn't have gone anywhere. My parents would have grabbed me pretty quick. But in my mind, and to this day in my mind, when I'm near the sea and I'm near a boat, I'm connected to everywhere. And that's something that stayed through me the whole time. I'm Iain Percy. I started my life at university, in a university studying economics, and finished in 1998, and then went on to become a sports person in the sport of sailing. Many people don't credit it being a sport, but the reason for that is it's a very interesting sport that tests you on lots of different levels, and it's really been the introduction for me into other areas of my life. Sailing is undoubtedly a physical sport. But it's also a technical. It's also a decision-making exercise. And for that reason, I think it's a natural sport to move maybe on into other things. And from that, I went on to a part of our sport called the America's Cup, which is really now the next step into being a technical engineering challenge and less of a sporting challenge. The America's Cup is a really interesting competition. I'll touch on it later when I talk about simulation in more detail, and really was one of the forefronts in simulation really because of the rule. But for now, the America's Cup is about a 90% technical race and a 10% sporting race, very like Formula One. Everyone knows Lewis Hamilton's a fantastic driver, but they also know he's going to win. He's not going to win if he's not in the fastest car, and that's pretty much the same as in the America's Cup. I had a few life-turning events over that long turn of my sailing career, of my business career. One was a good Olympics, of course, that opened opportunities, changed what I was going to be doing. I was planning to be working more in the finance sector where I studied. Now suddenly I was in sport, and so grateful for the opportunities that live. I then had disappointment. I had failure, and that really spurred me on, maybe more than anything else in my life, to not to always succeed, absolutely not, but to always feel I've put everything into a project. And that's something that stayed with me after failures in the Olympics, failure being a sixth. I mean, it wasn't, you know, in some ways it wasn't, but for me, it was a very, very influential in my life. Then I went on to team up for 2 Olympics with my best friend of 25 years, Andrew Simpson. We had amazing success together and great times, and that was, you know, the start of my learning about building teams, about the importance of sharing responsibilities evenly. We started as a partnership. We built to a team of 4 to 6 to 8, but it was always a partnership and a team where people had personal responsibility, and they weren't always rewarded financially, but they were always incredibly dedicated. And that was such a wonderful time in my life, which came to a real tragic end when Andrew died in 2013 in an accident at sea when I was with him. And that has to be, along with success, understanding failure, and then understanding that loss, is probably the other biggest influence on my life. And I know those who know Sir Bernard, and I speak so warmly of him, will understand that when you lose people who are that special and that in life, and especially you, it changes you also. And in some ways for the worse, of course, but some ways for the better. And I would say in that life became even more dedicated into work, into being driven, into trying to achieve things. It's an escape, of course, for some people in those moments. So those moments have shaped me, and they probably have overdriven me, as you said, you know, to doing things, you know. And I think as I get older again and now have a child, I probably re-looking again and thinking the next chapter has to have a little bit more balance. The next chapter has to have respect for the people in my life outside of work. And I think that's going to be the chapter I'm really looking forward to, and maybe isn't quite as intense, maybe isn't quite as driven, and hopefully still successful, but in different ways. And that was a little bit of the start of Artemis Technologies. Artemis Technologies was... Artemis Technologies came about in 2017. We had finished the America's Cup. We had this amazing team. I wanted to keep our team together, and one of them is here, Roman, our technical director, tonight, and evidence of that strength of the group that we had at that time. But we also wanted to do something with longevity and sustainability in every sense at that point. So the mission of decarbonising maritime is the official reason we started this, but the other reason for a couple of us is sustainability of team, sustainability of successful working practices, for want of something more interesting, of working relationships that you knew you could just call on and solve problems quickly with one phone call or one chat, and you've got and worked together. That satisfaction you have when you have teams that are humming. So that was the other reason we started. And then really the motivation for the decarbonisation was from the outside in. In 2017, the International Monetary Organization sent out challenges that we had to reduce emissions by at least 50% by 2050. Some scary figures around the maritime sector. 940 tons of CO2 gases every year, but the one that really gets me, and I said this last night, 200 ships, the largest 200 ships pollute more than all the cars in the world. So it really does bring it home how bad it is. The other change in 2017 was the rules had changed, and we'll talk about how we create these craft in the America's Cup later. But ultimately, you're driven, like you are in any of these sporting competitions, by the rules, and you end up trying to produce the optimal thing within those constraints. So it kind of changes. But the way in which those rules were written in 2017 hit towards speed, which in a way you're always trying to go faster, but you're trying to go faster within a rule. And if a rule is a boat has to be 25 tons, which it was previously, you didn't go very fast. You went a little bit faster than the others, and it was actually an equally difficult challenge. But the end technology wasn't necessarily applicable or useful to the wider world. The America's Cup in 2017 produced amazing flying hydrofoiling craft that were going incredibly fast in incredibly low bits of wind. And I think this video was one that I made, if I can go the right way for everyone. stunning efficiency of Artemis Racing's latest sailing craft gives me hope that man's ingenuity, coupled with the force of nature, is enough to overcome the challenges of climate change. Let's place the Artemis Racing boat in the Amazon River. Imagine there's no wind at all, but there's a 10-mile-an-hour river flow heading out towards the Atlantic. The Artemis Racing boat starts floating along with that flow. Just like riding your bike, that movement creates apparent wind over the wing. And here comes the amazing part. With that 10 miles an hour of apparent wind, our boat can sail back up the river at 30 miles an hour. Let's recap that again. With absolutely no wind at all, and a current taking our boat out to the sea, we can fly back upstream to the source of the Amazon. It is the challenge of Artemis and others to take this amazing technology and use it to find solutions for a sustainable future. I haven't played that video for a while, so I'm always kind of wondering when I'm going to get challenged on it. And this is probably the place with a room full of academics, so probably have a watch what I say. And this definitely catches as, you know, one of our best hydrodynamicists is always pointing out that the wind will, you know, interact with the water. It'll be pulled along by the water. So actually that boat floating along with the tide will have absolutely no wind, at least for the first few meters, and by the top of the wing it might have a little bit, but it's certainly not going 30 miles an hour, so stop playing the video, is what he says to me. But he does say there'll be a moment when the river flow has just changed and the wind hasn't yet built up that shear and attachment to the water. Well, that will be true because these boats were going 4 times the speed of the wind. So they were going 2 times the speed of the wind, zigzagging, but velocity made good, as we call it, straight into the wind twice. So, and going away at 3 or 4 times. So really stunning efficiency. So it was, the challenge really was, we had an amazing technology. We had a maritime industry that was polluting very, very heavily. And why was it polluting so heavily? Well, I believe it's because the maritime sector is by its nature not under any one country's eye, under any one country's regulation. The bodies that it have, although the International Maritime Organization is a very well-meaning and a great body full of very passionate people for the environment, that's not their only role. But they don't really have any teeth. You know, at the end of the day, the regulation in France is made by the French government, and if the French government slapped a load of taxes on very, very dirty maritime diesel, all the French ships would come and fill up over in the south coast of England, or maybe they would offer a man until recently. Might have a little war on the way now. But as a result of that, it's not so much the global emissions, although it is about 3% of total global emissions. And of that 3%, about 30% is domestic, which is where we started to come in. But as I said, it's that real aggression of the emissions. You know, sulfur dioxide is one of the largest contributors is the maritime sector. So, you know, one thing when we started the company, myself, Roman, and a few others, we didn't have much hope that true internationalism was ever going to get its act together and create a global set of rules that would encourage social, environmental costs to be inherent in the pricing of the shipping industry. Now, we all, you know, and it's certainly not unique to shipping, but we didn't hold much hope that that was going to happen. So we realized that we needed to create products that both decarbonize, were positive climate solutions, but they didn't rely on government intervention. We weren't particularly thinking government intervention was going to come very fast. The other part of that, therefore, was we had to be realistic about consumer attitudes. And one of the interesting things we've been doing with our modeling on the economic side is really trying to understand the consumer behaviors and trying to put now values on it. But to date, our factor for humans' preference for environmental solutions has been a factor of 1. That's how we've treated it because we want to be, you know, brutally realistic about our solutions. And I'll come to how that influences the decisions a man makes and why getting those factors correct are as important to us. So we, to make a difference, and I went to a talk when I was in San Francisco from Elon Musk a long time ago, and this is, I think, how he articulates being very, very rich and also making a climate solution. But in a way, he's got a point when he says, you don't change anything if no one buys your product. And that's something that we're always having to battle with, I think, as racers, as people who are used to trying to create the most efficient thing, the best thing as we would have thought of, which is the fastest around the course. But there is really not much second-hand trade for America's £100 million America's Cup boats, that's for sure. So it isn't a viable product. It's not decarbonising anything, however efficient it is. However amazing it is, it goes 4 times the wind. It's not changing anything. And that was part of the dissatisfaction of being only involved in something like that. So we needed to produce products that made a difference. And that's really where we turn to our background in simulation. If I'm going the right way or the wrong way, I must clicker here. How am I the wrong way? There you go. I'm good at this, aren't I? Pro. I'm in a room full of lecturers. It's not good, is it? So, why was our company so invested in simulation-based approach to understanding technologies? Well, it really does come back to this America's Cup rule. The America's Cup is a funny competition. It started in 1851. It's the oldest sporting trophy. And it's based on a set of rules that were written in 1851. So you can imagine they didn't have much thought of where technology would go, and they certainly didn't have much thought about where sporting competition would go, media rights, commercializing sport, professional sport. None of that was in their mindset. So the rules of the competition are funny. But they're kind of beautifully simple in the sense that it is the winner of the competition gets to decide the rules. Pretty much is how it's written. And so I was asked a good question at the table last night. How do the winners, how do they make that decision? What motivates them? And I thought it was really good. I've never been asked that before. And generally they're motivated by making sure they don't lose the next time. That's their general motivation, because they're kind of coveting winning this 170-year-old trophy like it's the Lord of the Rings ring, So most of it, if we're honest, it's about coveting, not losing the trophy. Sometimes it's about a genuine desire to grow the sport. Sometimes it's about wanting to have, and I think the cup that I talked about was a part of that. It was about trying to make something that was exciting to watch, something that touched with the next generation, to encourage more people in the sport. Sometimes it's because, when the head of Prada clothing wins, he loves beautiful yachts, and he wants to have old clipper 70, 90-foot things that look beautiful, but doesn't really think much beyond that. So they're motivated, frankly, by whatever they want. But because of that, it tends to change in quite a random walk over time. And it means that, and then coupled with the fact that you never have time to really make more than one boat, sailing and the America's Cup specifically probably lived in the concept of digital design and digital twinning earlier than almost any other sport. It was not ever iterative. We didn't have the Formula One culture of making an axle better each time or getting the tyre grip to be better than it was the season before. It was always, we didn't have tyres this season. We were doing 2 wheels, not 4. So everything had to be back to first principles. So this concept of performance prediction, and as we used to always call it in sailing, well before some of the concepts of digital twin were ever thought of, we were called it velocity performance prediction, we used to call it, and it was just started with very simple equations, just like aerospace do, and then as built, and like all these things, the simulations are lots of different levels of fidelity, and only as much as you put into them. So how do we work it? And just wanted to cater to the academic audience. So basically the diagram here was trying to say that when we see the digital world and when we have a set of rules from the America's Cup, we aren't starting at that point. So as teams, and the really important thing is that you're trying to beat time. You've got to race 2 years' time, you're trying to beat time, so you can't start with nothing. But you don't have a rule. But there's many, many things that we interact with when we race that are consistent, even if the actual craft is waves. Great stuff out there around wave modeling, really, from one of the academics here, and it was very in line with the work we do about trying to simulate wave modeling. But I think what the diagram shows here and the work you have out there with some of the open foam CFD work on waves is that's great for understanding problems with a degree of accuracy. Of course, there's many assumptions, and if you don't have assumptions, the problem just gets bigger and bigger, as you know. It takes longer and longer, and that's not practical in a race against time. But other times you do need that level of accuracy to understand a problem. Some things by their nature are high fidelity. So this link on the one on the left from high fidelity to something, a database, and then out again to something that might be a real-time simulator like that we saw in the top left. Those links back and forth, that feedback loop, is something that we work really, really hard to maintain and capture. And it was described to me once by a guy called Tony Pennell, who's a Cambridge visiting professor, but he runs the British cycling technical team and has done for the last 3 Olympics. And when he was trying to describe this diagram to me, he said, there should be nothing that your team, it was when we were a race team and he was helping me with Artemis, he said, there should be nothing that you've ever done or ever known that isn't somehow captured in your code, in your database somewhere. Because if it's not in your code, it was a waste of a thought, because it's not there, it's not referable, and it's not used in its interaction with your general decision making. So, be it real-world testing, where we're trying to validate some of the models in the top right, be it the way in which the CAD will draw geometries that we want to test, that needs to always be consistent and needs to be recorded, as does the databasing of it all. Of course, those who are involved in the databasing world, how do you database different data sets? How do you bring it together? And then an area I'm really interested in is how do you make the overall system efficient? How do you make the overall system work together so when you are trying to design a race boat or a zero emissions boat, it doesn't take you ages to answer the question, or put another way, you don't have to turn to a really low fidelity solution to answer the question to save time. So it's all about global control, design tool efficiency, and trying to do batch runs, have your computer systems able to run things so you get automated reports, silly things like that, automated reports of variable understanding. So, but everything we do is always physics-based. It's always got a human in the loop at some stage. We try to minimize the touch points, but there's always a human in the loop at some stage. And we're not actually, and maybe wrongly, very heavily involved yet with AI. And I think the reason for that is our history in the America's Cup. AI by its nature needs something to learn from, to have some data, and we never had that. Our competition was always won or lost on the day you launched the boat, because if you had a lemon, you weren't going to do very well, and you never had any time at that point to fix it. So we were always about, now, yeah, you did a lot of data analysis about once you had the boat to try and improve systems. So there was that feedback, but it was quite late, and you were already in trouble if it wasn't fundamentally a good global system. The other aspect then, of course, which was very new to us as a race team, was introducing the concept of someone having to buy your product. So someone has to buy it. What is going to motivate them to buy your product? And therefore, there's going to be a net total of CO2 emissions and environmental benefit that comes out of those sales. And obviously, if there's not very many, it's not very much. And so that was an interesting metric, and because there was also the metric of the sustainability of the company in a financial sense. And when they sometimes clash is when it's also a really difficult metric to find. The first thing we tried to do is trying to use that same systematic analytical approach that we do to the physical world in terms of making machines, understanding how they're going to work, to the economic world, and then trying to marry them together. And just like all our models, and myself and Roman talk about this with our simulation guys all the time, start simple. Start simple and build. Start simple and build. Make it a demand-led process for simulation. When you are struggling, when you think your simulation is not answering the question, it needs more fidelity or more accuracy. When it is fine, We're not here to make the world. We're not academics in that sense. We're not trying to make the best. We're trying to do it against time too. So we're trying to find models that work. So, at its very simplest, our economic price model was saying we're a ferry operator. We want to have a zero emission solution, but we can't pay any more. There's an original capex cost of a diesel ferry, and there's an original capex cost of a hydrofoiling electric ferry. The hydroelectric makes a big drag gains, as we'll touch on. How do we time those? What's the crossover? It started like that. Of course, we then tried to increase some of the subjective factors, et cetera, but it starts like that. So we had two models. We had an economic model. We looked at lots of things. We actually looked at wind propulsion on ships a lot, again, absolutely motivated to use wind propulsion on ships. I love the sea, I love sailing, and I don't like emissions very much, so it's right up my alley. But when we do the sums, the payback times are in the 25 plus years. And so I want people to take that on. I want governments to enforce that to have to happen, and other zero emission solutions for large ships. But we didn't have technology that could solve it in 2-3 year payback times. And so the result of that kind of study and that work was what we're producing here in Belfast, which is the Artemis e-foiler propulsion system. So in its simplest form, it's really, there's a lot of technologies here that have been done before to some extent, slightly differing ways, bringing together of technologies. There's not that much first principle new stuff here. There's obviously parts that we patent that are small aspects of what we do along the way. It's not saying that there's not invention, but we need to say that there are parts of it's a combination of known technologies, really, at some level. Not easy stuff, that's for sure, and the combination, as we know, of separate individual subsystems that's a lot of complexity, and I'll touch on some of the aspects that, in that sense, are novel, even if the core stuff is not new. So the hydrofoils really was our backyard. The hydrofoils have been what we'd used in the America's Cup, which were, as we discovered, were able to reduce drags at certain speeds and at certain weights. The drag there's a significant drag bucket, and it started much earlier than you intuitively think. It starts way before you've taken off, when you're sharing lift between the displacement of the hull and the foils is already making huge gains. But certainly when you take off, there is another drag bucket jump. It's never going to, it really is a relationship between weight and span. So, there's companies in San Francisco that raised a couple of $1 million, I saw, for a super tanker which was a normal super tanker and had a hydrofoil, and some investors in Silicon Valley gave a couple of million. If they could have read one paragraph of a naval architecture book, they wouldn't have spent that $2 million, but they didn't. So good on those kids, but I think it's gone bust now. You're going to need a wingspan of about 30 miles to lift at the speeds tankers go. So, we're not, I guess what I'm saying is we're not solving worldwide maritime with our problem. We're very much targeting one area. And this was really about the simulation again. We wanted to go to areas where, A, we had competitive advantage and knowledge. 2, we could see quick payback times that thought it'd be sustainable for customers to do it. And that's in this high-speed domestic maritime. So the foils reduce the drag. Of course, the foils that we have, which are, inherently unstable in the sense that there's no surface piercing aspect. The foil is a wing underwater. As anyone who looks at the ocean knows, the waves it's a very turbulent sky. So the challenge for us is being able to go through waves and keep stable flight. So why wave modeling for us is a big part of what we're doing as the control systems are reacting hundreds of times a second to the change of angle of attack and the forces that implies, be that feedback from sensors of the boat state, boat position relative to water, flow over the foils, all these inputs from the sensors are coming in. But essentially when you're doing in the simulation world, you need to have a good understanding of the wave modeling. But then some other areas that we incorporated and have taken on and developed, we've developed our own electric drivetrain that's housed within the water, which is novel. That isn't done anywhere else. And that's really a case of allowing us to remove shafts. So it would just have wires leading down the vertical shaft to the foil, but it does come with its complexities around having 800 volts underwater. But the structure, to put it in perspective, the engine has no real extra drag because the structural requirements from the regulation of that T-joint require a larger frontal area than the MGU itself, the motor generator unit itself. So you can imagine how small and how power dense these drives are nowadays. So we took a motorsport drive and had to adapt the core technology within that to create something that's suitable for our duty cycle, which is a bit different to motorsport. We're pretty up to speed in cruise in Maritime. There's not that many traffic lights out there, so it's a different duty cycle than motorsport. Well, there's not many corners either. And then our marketing director would always kill me if I didn't point out, because all I care about is the efficiency of the drive, how it works economically, and it makes sense. And he always bites my head off and said, it's not about that. And it's about other things, like the fact it's comfortable and you don't get seasick and there's no noise. And he's kind of right, because I remember when I was in San Francisco and we were talking about the technology with them, and they honestly, the only thing they kept asking was, will I be seasick if I'm on your boat? Will I be seasick? I mean, no, but if you look at the fuel savings over time, you'll be, will you be seasick? So he's kind of right, but he still don't like it being about that. Those secondary things of wake and noise and comfort is something that, hopefully will bring more to it than just the fuel savings that the base technology has. And then there's some really secondary technical requirements, which is where we've partnered with people here in Belfast, which has been really quite fascinating. So it's always quite funny being here in Queens, talking about the two projects that we work on with the engineering department, because I feel there's a slight contradiction between the two. We're working with one group on collision avoidance and one group on impact. So I always think they're kind of covering each other. So if one group don't do a good job, we're all right, we're covered by our mates in the other department. So, no, but that collision avoidance technology out of the work that's been done here, obviously with a view originally to other vehicles, but adapting that to have to look at subsea objects is something that, we're really lucky to have Queens involved in. It's something that, I think quite unlike university collaborations, this project feels like something we can leave and it's going ahead well. And that, often our collaborations, it's been a real, there seems to be in the university here, quite a kind of commercial mindset to making solutions rather than just research, which as someone as a business collaborating would find really, really valuable. Autonomy too. I mean, we have a lot of autonomous systems, a lot of kind of closed loop on board autonomous systems. One thing I learned as a sailor, I had to long ago not think that I was very good. The computer would always beat a sailor in these kind of craft. And the only thing I was any good at relative to the computer was sometimes making race decisions, game theory type decisions. But when it came to a reaction to some state, I was always useless. And if anyone comes to visit our simulator, it's a pretty humbling lesson because you set it up on a windy, wavy day and the autonomous flight control has you going just fine. About 10 seconds afterwards, you get a pretty nasty smash because it's really hard to react fast enough to the change of angle of attack. But for us with autonomy, we never had to think about what that meant for cybersecurity or what would happen if someone else got involved with those systems. So being here in the Belfast region has been very, very powerful for that. Batteries, the batteries there is something that's a really interesting subject. We're trying in a way to be agnostic to the fuel source. Another question I had earlier, which I lied from the students, was, what do you think about hydrogen? What's your feeling about the hydrogen solution? And I must say, I'm certainly no expert. I'm trying very hard to meet companies and academics on this subject because, one, if I'm brutally honest, is we have an oil and gas investor and they would love the energy transition to involve a transportable product and are very interested therefore in understanding themselves, so I get pretty clear direction to make sure we're understanding. But I also know that when I put the cost per kilowatt hour of hydrogen into my economic models, people are buying our system. I tell you, efficiency is rewarded a hell of a lot more when the fuel price goes up. And interestingly, one of the biggest variables on our success is diesel price, because it's always a relative saving for us. It's OPEX savings, and actually our bit's quite small, so it's all about what really about the existing costs are, which is pretty much down to diesel price. So for us, diesel, if suddenly the only option became hydrogen, it's pretty good for someone who's looking at 60% drag savings. So we're interested in that. And the battery side, though, is a short-term, potentially longer-term solution for us as a company. But we've developed our own battery here in-house, which is, Roman sitting over there. All of this stuff we developed ourselves. I mean, obviously, you partner with some consultants, you partner with some aspects, but the drive on the battery, to put it in perspective, is our total system cost, which is, if you pretty much think of the boat down, is about 1/3 foils, 1/3 drive, and 1/3 battery. So it was kind of a bit remiss of us to pay £500 a kilowatt for a battery pack when for a not insignificant amount of non-recurring engineering costs we could produce for 200. So we were silly not to. So we got ourselves into battery and had some really cool safety concepts around that. So, it's been a fantastic collaborative process with the universities here, with the harbour. I think the final thing I wanted to touch on from a kind of academic look at us as a company trying to produce green technology was the finance side of it, because I think for me that's the last piece of the puzzle, because what we tend to be doing is producing efficient things that cost quite a lot, but not as much as 2-3 years you'd be back to even, you're way ahead, but ultimately that's a finance question. And I think that's when that side of risk, managing risk, finance, technical risk, financial risk, cost of borrowing, and bringing that into it is where I think we have a real opportunity in the region here, dare I say, in the City of London with their banking sector. And if we can be joined up between those areas, I think that's where we have a real chance to, where arguably Northern Europe missed out compared to the US at some level, let's face it, in the tech revolution. I was in San Francisco for 5 years, and they were booming in those 5 years, let me tell you. So we have to say we missed out to an extent on that, and I don't mean that much respect to particularly this region with the work that's done in the tech sector, but I think with the green revolution, that's for me the way we can unlock this and I like it because it's a little bit more European in our thinking compared to the US, because I think it does need government intervention. I think it's that marriage of policy and regulation, government and risk sharing, both in the development stages we are benefiting from through our project, but also in the sales finance and risk sharing of longer term purchasing of expensive assets, and banking sector and finance. And I think it's that middle bit where government need to have a role is something that in Europe we have a bit more comfort with. And I think if we can embrace that, I think there's a real opportunity to lead in that green tech, and something, I do get good engagement from, I must say, from governments here and over in Westminster. So why are we here in Belfast? I was talking last night to an investor group, and I was able to speak very much from the heart about my experiences about coming here to Belfast and why I very much have enjoyed it. I've touched on it already. The collaborations here with Queen's has been easy, it's been grabbed, it's not been met with suspicion, it's been met with, okay, cool, let's try and make this work and let's do a project. And that is not that normal. I set up a race base in San Francisco, I've set up a race base in Bermuda. Bermuda wasn't bad from that respect, actually. They were small and excited and into it, but they didn't have any kind of scope or skills. You see, and I feel there's a sweet spot where people still have a drive, they still feel they individually or as an organization can make a difference, so they're motivated and fired up, but also has skills. And I think that's what's been so satisfying here is that combination of can-do attitude, but with skills at all levels, actually. And I did a real shout-out last night also to Belfast Met College, who we've worked really well with on the training of our technicians, and we've started an apprenticeship course there. And something of the things I'm most proud of, that the students are starting learning about high voltage, about composite engineering there, and a course that we've co-designed with the college. And I think there's some real gems like Queen's, like Belfast Met, that make this place quite special in terms of the skills. And I think the shortages that we see in skill, I tell you, in the supply chain, it breaks me, but also in terms of skills, it's when you really brings home how important it is to have that. And I think the last thing I said, and I said this last night too, that the people we work with here feel invested in the region. I think if you're living here, you're not, a lot of people in London or San Francisco when I lived both were transient. They weren't grounded there. They were there if you were paying as much money as New York, San Fran, or London was. Otherwise, you were going. There's a lot of highly, highly intelligent, skilled people who are grounded here. And that feels great when you're building a business. When I come back to the pain I used to have with the America's Cup, where you stopped and all those built relationships and understanding and processes stopped, that's great that you don't feel you're doing that. When you work as a group, you're investing in the future because people love living here. I love living here, So what next for us? I'm hoping there's going to be some really exciting stuff coming out of this, out of the consortium in terms of maritime technology. And by exciting, I mean exciting to us, what we're doing, exciting to the academic colleagues we're working with, but also I think visually exciting and motivating and promoting of the region, which it's not maybe something that kind of technically I worry about, but I do understand the importance of that. We need to get buzzes about places. We need to get people realizing that there's some special things happening. And I think when we launch that vessel that I had the infographic on early next year, and there is the first ever flying zero emissions electric boat of any size. There's some small private craft that's out in Scandinavia, but with outboard engines, and when we're really launching something of size that can really go for 60 nautical miles flying above the waves, it's transformative, it's pretty visually cool, and people are going to wake up to what's possible. Following on from that, there's going to be much larger vessels flying up and down. If Belfast Harbour Master lets us, anyone here from we've done a lot of good simulations of how little wake we're going to do and how little noise, so we'll get ready to share them with the Harbour Master. But you touched on it. I think something I'm also really excited about that's coming up is the Green Seas project we're collaborating on. I think understanding how we know we're a small part of an energy system, of a transportation system, and understanding not only where we sit, but learning more about it in general. We talked about hydrogen, how that can fit in with wind power and hydrogen, bunkering of hydrogen. Do we have hydrogen on our boats? Do we use hydrogen as the buffer for the energy system, and we still use batteries? Where are the constraints in flexibility in the grid? Where are the constraints around speed of charge versus at sometimes using fossil fuels? I think that's really quite interesting as well. And this is the start of it, but that kind of global system understanding is really interesting to Artemis Technologies, and that's why we're a very small part of that Green Seas, but we're there very much interested in trying to understand where we should pivot our technology, and also where it'll fit into global transportation and energy systems. So I guess to finish up, I think there's so many things we want to do and so many directions we want to go in, and we try at the moment to be quite targeted in bringing our first product. But to do that, we need so much talent, and we have found talent. I think I've built a team here, and actually I have to credit most of Roman, because I'm talking really about the technical team here, have built a series of technical heads that I feel can solve difficult problems fast, working collaborative. Of course we're getting better. Of course we've got a long way to go to be really working as slick as maybe we were in 2017 when we were a team of 100 who'd worked together for 6 years, but there's certainly talent there, and it's certainly starting to gel. But we don't have all the answers, far, far from it. And we're a place where intelligence and dedication will be listened to. I think we're a place where we accept what we don't know, and that's why we're so proud to be working with our academic colleagues. And I think we want to remain to be nimble. We want to continue to be nimble to know where we can pivot. And I guess coming back to the kind of central theme of being systematic and simulation and fact-based in the decision-making is something that we will continue to hold on to as a company. So when hydrogen, if it became the driver of maritime fuel, drove a different derivative on efficiency, we'll be having much thinner carbon fiber foils, whereas today we might have a steel hybrid because the cost of fuel is lower. We'll stay systematic, and we'll be very adamant about that. And I guess with that in mind, finish by saying we're looking forward to working with all of you in the future, because I feel at home in an academic audience, although my academic career was a short undergraduate, despite the fact they gave me a doctorate, and they only ever mention it in universities. But I really look forward to working with everyone, or a few of you in the room over time, because I think that's where I like to think as a company we share values with the academic world, that we want to work on facts and we want to make decisions for the future of maritime. So thank you very much. We're a small part of saving the seas, the race to sail the seas. We're a very small part of it. You as a university will be a far bigger part, but collectively here in the Belfast region, I really think we can once again be a leader in the maritime sector. Thank you.
Thanks very much, Iain. That's a terrific talk.
Thank you.
Enough to keep us going for weeks there. So digesting that and coming up with interesting questions for you. So that was terrific. We're going to have Q&A with the room here, and also potentially some folks joining us on YouTube. So I'd just like to start off with one question of my own. And I was very interested in the speed at which you're having to turn around designs for the America's Cup, and using digital modelling quite a bit ahead of the rest of us, I suppose. You talked about needing to capture all the data and bring all of the data from the various sources into your model. And I'm wondering, how do you how do you balance that against the very fast-moving, volatile, uncertain environment that we have sort of worldwide now, whether that's political, economic, financial? How do you allow for that uncertainty within your modelling?
I'd say not particularly well, if I'm honest. I think because we're good at handling our uncertainty in the physics world, looking at its sensitivities. I think, and so theoretically we've got a good handle of it, in the sense that we never create optimums. We always create an optimum and coupled with a sensitivity, because it's really, really important to understand what it's certainly in a sport like sailing, you are never at the optimum. So you have to understand if it's not going well, what variable it will be. You have to adjust, mainly because our sensoring is weak. We don't have weak. The world's very unsteady. The flow of air is very unsteady. So you don't have much normalization of power, if you like, input power. And so you're even with optimums, you're looking to understand why you're not quite there, and so you need sensitivity. So I think one of the things our simulation engineers are very good at is A, assumptions, letting you know what the assumptions are, and B, what the sensitivities are around any supposed optimums. So then when you turn to your specific question about the economic world, we have sensitivity, so we try to continue that modeling. So we do models where we have ranges of these variables, and we try to understand what that does to the global pricing that we should have on a product. But it's not, the funny thing is, I guess it's because it's not come from our technical team, and there's only a few of them that are interested in helping, is the truth. So that's why I think I'm interested in that, because I had an economics and maths background, and I've always interacted with a few of the top race designers, so I drag their knowledge into doing some Monte Carlo simulations and stuff to try and understand the variables. But it's not their area of interest. They're really good at doing that on the physics side, but I have to drag them over to help me and try and explain how I might understand these sensitivities and what it might mean. And it is really important for us, because I touched on it about the delta, the OPEX delta. It's so much more dependent on the external factors than it is on our factors. And it is really difficult to, if diesel gets really cheap, we're a hard call. We are a hard call for a business, and that's the challenge. And I guess the other way we deal with it is by trying still, I said we don't rely on governments, but we're not shy of talking to them about enforcing regulatory changes or taxation or alike to try and balance the curve in our favour. I mean, that's the bottom line. We are passionate about decarbonising it sustainably, economically and environmentally, so some of those uncertainties are influenceable. Domestically, probably only at the moment, as I touched on, but I think they are.
Very good. Thank you. So we have a roving mic available to go around the room. If
no pressure.
Wants to ask a question, could you put your hand up, please? Tell us who you are and what body you're representing, and put your question to Iain. So the floor is open.
Hello, I'm Emma Flynn. I'm Pro-Vice Chancellor for Research and Enterprise here at Queen's, so I'm going to take the prerogative for asking the second question. This is a great challenge, and I think the interesting thing is it's an interdisciplinary challenge. You've got your chemical engineers, you've got your maritime engineers, and you're also going to be thinking about management and economics. What are the challenges about working with an interdisciplinary team? Or the opportunities?
Yeah, well, there's definitely that. I was talking actually to the students about that today, because they were saying, what do you regret about the way in which you work with the teams you've built over time, which was a great question. And the answer I gave is not giving feedback to people in the way they want it, but giving feedback in the way I like to give it. And not in a, I want to give it that way, in the sense that's just naturally how I give feedback. And when you work with people from different disciplines and cultures and ages and different people, but mainly it's just that people are different, and they might tend to subgroup by their kind of academic or working interest, but people are different, and if you always are trying to feedback in the way that you're comfortable with, you're not always getting the best out of people. And so I guess my inability sometimes to adapt feedback to the customer rather than the giver is something I regretted. But I think that is probably reflective of the interdisciplinary challenge that is felt by all those teams on a daily basis, is that kind of different way of working, different way of it. It's like myself with the marketing department who keep telling me to shut up, the way I keep trying to say, when we see the customers, we need to start telling them about, the function that we have for, he's like, they're just going to glaze over. They're not even going to listen to you. So why do you keep telling them? So it's, so I'm obviously reading the audience wrong there, and I think that it's that reading the audience wrong that people probably have between the different disciplines as well. But my belief on that is, and well, we've dealt with it with teams, is becoming genuinely close and relaxed with the people around us. I do not believe the solution is to be stricter or to impose. I believe it's to be more open. It's to try and understand global strategies collectively and then give freedom to individuals to deliver. But please make them relaxed to just ask a question and talk. And that, for me, involves outside work interaction. I think it's important that people know each other quite well. It's not always easy, people have families, people have lives, but if you can have those touch points where people feel to the point that they're comfortable enough to and approachable enough to say they're not understanding something and to explain, and it's not, otherwise quite often these things, they split apart and people get embedded in one thing and the other one embedded in the other, when actually they're just seeing the same thing in with their own lens. And so perspective, I guess, just trying to make sure people understand and respect perspective, and certainly something I know I need to work on and not always good at.
Thank you, Iain. Alan Watts from the IET. I was very interested to understand the potential sources of the core power, where the energy is coming from. And understandably there, you concentrated on the foils and the batteries and all the stuff you've got to get right first. But your diagrams didn't show where the energy was coming from. Now, I was privileged to be introduced to the company a couple of years ago, and some of the initial ideas I saw, I mean, you could obviously power the batteries, go into land, recharge them from wind turbines or whatever to get zero emissions. But I also saw concepts which had very complex, I think, computer-controlled sails on them, which basically meant if there wasn't enough wind, you would go on the batteries. As soon as there's enough wind for the wind to take over and power the craft, it could also then you could reverse the motors and you could recharge the batteries. And I'm sure all of these things are possible and will probably be dictated by the markets you eventually commercially go into. I wondered if you'd just like to comment on where that might go, and I'm particularly interested in the computer-controlled sails, if I read it correctly.
Yeah, well, the first thing to say is that's been going on for 70 years, wind power, or hundreds of years wind power, but regenerating power. When you see, people out cruising around these isles, they'll often have something chucked out the back spinning, and that's generating electricity. So that concept of using the wind to produce propulsion and using excess, if you like, or burning off speed in return for power has been around for decades. And certainly we looked at that very closely. And so the reason we don't have that today is we looked at and took quite high fidelity models to a level where the bottom line is for a boat that could take about 20 tons of cargo, and we had an average of 14 knots of wind, so a reasonably windy-ish day, we could unlimited go, and we could handle up to about 12 hours of no wind on a dip. So it was a craft that could go forever. To achieve that, it needed pretty America's Cup level of lightweighting, so it was a very expensive craft. But particularly what was interesting for us is a lot of the ability to go that fast, be that efficient, was coming from the hydrofoils and the electric drive. So we modeled it without the wing, and we modeled it in respect to the cost, and basically they normalized for the payback time for a potential customer. One was 3 years and one was 20 years. So the wing was, yes, working physically, and as I said, in a very slow speed way, it's been working for decades, but it could work at an average of 25 knots, unlimited, with an average wind of 14, as I said. So pretty amazing technically, but not amazing economically today. But I still, I'd love to do that kind of thing because it's cool, and I still think there's applications that want unlimited range. Sadly, probably more in the defense world or in ultra-high net worth individual world where they want to live out off the grid. So these things are there, and we do have clients who are super yacht companies making £100 million yachts, and we do engage with them on exactly this kind of solution. That tend to be where their clients want to go, and literally in this kind of project now, is they tend to want more luxury on board and weight, which luxury for them, let's say, lower cost manufacturing and more cargo in the commercial world. And really quickly you snowball to only being able to do this slowly. So being able to do that back, like the yachts are out on the Isles already today, you're back going 6 knots with wing sail, yes, regenerating on a very strong wind day, variable pitch props, coming back and propelling in no wind. You can do it for sure, but you're back at 6 knots. We wanted to be able to do it at 25 knot average, and you can, but it's up at a cost point that maybe it doesn't work yet today. Not many applications. There are some probably, but not many.
Thank you, fascinating.
I had a question. I almost let you walk to the other side, but I figured we'd be efficient here. My question is, and I'm thinking about electric cars, and you talk about the lack of noise and sort of the impact on wildlife with this. Because the reason I'm thinking about electric cars is the amount of times I've stepped off a curb and almost gotten hit by a Tesla because I didn't hear it.
Yeah.
And so I'm wondering... What's that?
Sorry about that. That'll be me around here.
No problem. But I'm just wondering, with wildlife, without the noise, I would assume the noise would push wildlife away, or at least warn wildlife something's coming. But when you have a very small footprint, as you have, and but you've got a wing going across, is there any impact that you have seen or anticipate to wildlife?
No, well, look, the collision avoidance, subsea collision avoidance, I think one of the primary things you'll be trying to avoid is reasonably large marine life. And yes, we haven't hit anything, but we have, our fellow race teams have hit sharks in San Francisco, turtles in Bermuda, rarely, but it's happened. So that was sailboats. That had no, well, not no noise, ropes and everything, but that had even less noise probably than a submerged drivetrain. I hope we have no noise, by the way, because I'm worried we might, Ramon's worried we might have a load of noise from some resonance issues. But so I think it was rare in our, and we did a lot of days, but it happened. There's no doubt it happened. There was some marine life hit. I think that there is enough noise for them to move, but I think there will be occasions where collision avoidance systems might be missing marine life as well as, say, a container or a log or something. But it's a concern because, I mean, you know, it's obviously a horrible thing, and in Bermuda, because the marine life that was turtles, it was obviously something, I don't know, wrongly, I guess, you get very more emotive about hitting turtles, and so there was a lot of work to clear the race area because they're a bit slow and not able to get out of the way. So I think it's something we have to consider for sure, because we don't want to hit any animals. But fortunately, in our probably 1,000 days, it's been one or two that have been hit in pretty heavily sea life area.
Thank you.
My name's Claudine Heron. I'm Chief Executive of the Commodity Trading Division of W&R Barnett. We move between 4.5 and 5 million tonnes of bulk liquids and dry cargo around the world. So I'm quite curious as to what you see the future being for those sort of bulk cargo ships and what technologies might come to help us out on our zero emission drive.
As I said, I would love it to be wind propulsion, being a part of it, but that's not really very scientific. It's just that I am a sailor, and that would be, to return to sailing would be a really, really cool thing. I talk to our investors who are also big traders. They're not particularly happy with the practicalities of wind, and certainly there's obviously routes where it would be a negative, so that's not going to be solved with wind. I think alternative fuel solutions, and we talked about hydrogen a little bit, where I see one of the best applications today is in offshore shipping, because you're a bit less volume restricted in your big ships than you are in a car or something. So cost is obviously the challenge right now for that with ships, but I think that could be a longer term solution for you. I mean, there's obviously utopia that you've got a lot of seawater and you're going through it, and can you drag it out? But I'm not enough of there'd be much more experts in these buildings that could say if that's ever going to be a viable solution. But yeah, I think, there's so much work going into alternative fuels, but, I come, again, not trying to dodge a question, because, I obviously know a lot about wing cells for ships and hydrodynamics of propulsion, but I'm not a massive expert on alternative fuels, which I think is probably where the solution is going to come from. But I come back to thinking that the real challenge for the international world is the fact we don't have any international regulatory teeth, so there's no way at the moment to take account of environmental or social costs, and I'm not sure there's going to be a cheaper solution than what we have today. That's the problem. We have invested here because we see it. It was something, as I said at the beginning, worked without subsidy or nudge, because we didn't have much hope that was going to happen. I think it's even harder in the non-domestic, in the kind of international shipping trading world, to take account of environmental costs. So it's either going to be some real coming together and changing of the laws, or some serious social conscience from companies like yourself to go away from really dirty diesel. So that wasn't a very optimistic answer, was it?
No, but thank you.
Denise, here in the middle.
Denise O'Connell, Northern Region Representative for Engineers Ireland. Iain, thank you. That was a really engaging talk. you talked a bit about government interventions, and I'd be interested to hear what your view is on what you think are the most impactful things that government can do in this space, and what those interventions really need to look like.
Yeah, so I guess it's the holistic thing that governments need to come together in my mind a little bit. So then whatever we're doing collectively, because I mean, our aerospace or maritime, otherwise it's a race to a bottom. But then say they were able to all do it collectively, or we're talking about domestic areas where you had some control in traditional government sectors. For me, there's two routes, really. You either do it through regulation or banning, like the talk of cars, or classic one for us would be the wind farm sector, or something would be a classic. You're producing wind. Every part of that operation today with these vessels could be zero emissions, and that could be enforced. That would be an easy start when you've got, we'd obviously like it, but there'd be some easy starts like that. Having some tax on marine diesel when there isn't today is a pretty shocking place for any country to be in, but they are all in that position pretty much. And again, that's not going to work internationally for the reasons we just said with trading. You just fill up in Venezuela and then cross you wouldn't head off from Miami, you'd go down to Venezuela first and fill up for a third of the price. So it needs to be for domestic probably at this stage, so we'd put taxation on. And then equally on the flip side, the subsidy, there's projects, there's tenders in Norway for ferries that is very simple. Anything that is saved below 10 is for like a 200 passenger ferry. Anything below 10 litres a nautical mile, every litre saved of diesel, you get €1 a nautical mile on this route. Simple subsidy. So in our case, where we'd be using zero diesel, we'd be getting €10 a nautical mile, and that pretty much equal to the fuel savings. So there's a subsidy model like that. So, there's got to be real things. Bottom line is, it's got to be real things. It's got to be things that are systematic in its approach and looking at solutions, and that will make people do things. That's why I'm encouraged, because I think in Europe there is a bit of a culture of that. Norway are paying a subsidy and they are charging on the tax. So we have a bit more of an acceptance of that here. And I think, I was taught in my A-level economics, social costs and real costs and them not being taken account of by standard in normal trade. We're kind of a little more at peace with that here, I guess, and I think that gives us a bit of an opportunity with the green tech revolution.
Thank you. More questions?
Thanks very much, Ian. Frank Given from Engineers Ireland. I was interested in not just the commercial side of it, but the technology side of it, in terms of people's understanding of the technology and how it compares to the incumbent technology. Are you finding that there's much of an appetite for something new, or is the user industry, still stuck in what they've got?
Yeah, I think there will be. We're not quite, we're launching this first vessel in a few months, so we're not quite at the point where we're kind of going to market, but it's certainly a concern. As I talked about the marketing guys saying to me, stop talking about the models, they're not going to care. He's also saying they are going to care about the fact that, what he's hearing is, I'm not comfortable if I haven't got a big tank of diesel on my boat, and these are the seafarers who are going to make that decision. To be fair to them, they're at sea, they're risking themselves, that gives them security. So I think, simulation models aren't going to sell to many people, and I think, I've spent 15 years getting more and more invested in building digital models, having a confidence in them, feeding back data and saying, right, well, what do you mean it's not going to work? I just showed you it's working in the simulator, and they're like, well, I don't believe you. So, I think you're absolutely right. You're not going to get people, you can't expect people to do a load of degrees in the field of your designers to understand that what they're saying is actually true. You've got to demonstrate. And I don't see there's such a world anymore for prototyping as we get more and more comfortable with digital, but I still believe there's a big requirement for demonstration. Now, of course, we talk about feeding about real data. There is a need for prototyping because simulation models have a lot of assumptions, especially real-time ones. So you know it's wrong, so you better get out there and check what wrong means. But I think essentially they're the things that over time you can get better and better handle on. But you're never going to convince the customers, I think, without them touching and feeling and experiencing. So I think we will have a big challenge. I think you're absolutely right. We will have a big challenge, and I am sure that some of their concerns will be justified. Some of their concerns might be things we haven't thought of. And so that's another reason, I guess, for demonstration and prototyping is testing the things you don't know yet. I don't think we should underestimate the challenge. The setup we're going to try and do on the sales front is very much with that in mind. It's about experiencing the boat that we have, experience charging, reassuring people around charging at sea, charging, at docks, flying in boats, having 800 volts on boats. There's a lot of things for people to have concerns over. So we're aware of it, but I think you're right. It is going to be quite a challenge in what is traditionally a quite conservative market. By its nature, it's dangerous. This whole. I get worried when my battery's low on my car, but you're a bit more worried when you're in the middle of the ocean. So. Rightly so, I guess, is the point. So it's a conservative industry, and this is pretty new in a few areas together. So we've got a bit of a job to do there.
Any more hands up? No, I think that's us good. And just one question from YouTube. So, Iain, the question here is wondering if Artemis is moving towards autonomous ship technology, and if you've come across any shipyards in Southeast Asia that are involved with this.
I have had some boats made in Southeast Asia, but much smaller ones that I've raced on in the past. But I know there's a really big industry out there. And in terms of the autonomous ship technology with regard to ports, we don't have much to do with that. Our autonomy is very much kind of on board. I'm involved only in the sense that our connections with the rest of Maritime here in the UK, we see, and the rest of Europe, which is probably actually, also really advanced in these areas. There's a lot of work. I'm a little bit less fired up about that because autonomy that takes away skilled seafarer jobs doesn't necessarily fill me with as much joy, and I don't want to be a Luddite, but I kind of always have this battle with myself, and we have these great things in ports around with pilots, highly skilled seafarers who know that region, they've seen it all, and they go out. However much I am being a Luddite, because however much I get the fact that there will be sensors that can do that and bring it into port. It really is, it's quite efficient already. It's a pretty big ships where only one or two pilots are getting on board. It's not like we're massively labor intensive in the maritime industry. So to get rid of the last of it, I think, well, good, but let's maybe concentrate on those ships not polluting so much on the way or being propelled in different ways, and focus a little bit less on the autonomy of the operation. But look, it's impressive, it's important, autonomy in general of systems is something that's obviously very fascinating and complex, and when it's done, it will work more efficiently and the ports will pop containers. But there's aspects of, my maritime history that has a lot of respect for those seafarers, I guess.
Very good. I think we'll bring the questions to an end then, if everyone's happy with that. And thank you very much.
Well, thank you all. It's it's such an honour speaking, and I must say, with the Q&As, being asked questions by people in the room that are much more qualified than you to answer some of the questions is quite daunting. So don't let me tell you that's not lost on me. And thank you for humouring me and let me stand up here as the expert that I am. Definitely not on a lot of the subjects you answer, but it's a real pleasure to speak to you all today. Thank you.
Thanks, Iain.
Thanks very much, Gerard, and thank you all. And thank you, Iain. That was wonderful. It was inspiring. It was fascinating. And you had so much content in there. It's hard to extract a few small points, but I want to just single out a few that particularly resonated, I think, with me and that I think will resonate with our engineering audience. First of all, I think you explained really well the scale of the challenge here, the scale of the decarbonisation challenge for the maritime sector. And for us, on an island that is so dependent on maritime trade, that has such a wonderful marine resource, and of course in the city of Belfast, with such an outstanding history of maritime work, and indeed such an outstanding present industry, as you described, I think it's really, really important for us to hear that message. So thank you for that. A few other things that I really enjoyed, your talk of the digital twinning. This is something that we encounter in all sorts of different contexts. Your description of it in your context was fascinating. The multidisciplinary nature of it, as Emma alluded to earlier, I think is so important. The fact, and you referred to this a few times, that you're always grounded in the fundamental physics and engineering, and that you always start simple and then build from there. And I think that's such a great message. And for our student audience, and I know you were talking to students here this afternoon, so important for students to hear that message. And so it was great to hear that. A few other points that really struck me, your emphasis on the consumer, that no matter how good your technology is, unless you can influence consumer adoption, that ultimately it is to no great avail. So I think that's a really important message for us as engineers to be aware of. You talked about finance and how finance has to be sought and utilised appropriately. And you talked as well, and again, another very important message for us as engineers, about the geopolitical context, and that often, no matter how good the technology is, if you don't have the ability to influence into the political system and the regulatory system and make sure that all the political instruments are in place to make this happen, again, the work can be to no avail. So again, it was great to hear that message so clearly and from someone with such experience of the issue. I loved your reference to teamwork, and in particular your teamwork and your collaboration here in Queen's. I thought it was great to hear of this. It's clearly a really successful example of academic industry collaboration. Great to hear about it, and congratulations to Juliana and Emma and all in Queen's who are involved in driving this forward. And you also really conveyed the excitement and the passion for your field. And again, for those of us kind of trudging through all the things we have to work through as engineers, we sometimes forget about this wonderful motivation that we have to do what we do. And I think you really brought that to the fore and really will have inspired the audience. So thank you also for that. And another thing that I really loved was your starting point, where you talked not only about your success, and we are so aware of your great success in sports and can visualize how that must have led to your success in business, but also your failures and your loss and all the other elements of the work-life balance that come into play as a career is built. And I think it's so important for us to hear that and be cognizant of that, particularly post-pandemic, when so many people have been dealing with personal struggles of their own and continue to do so. It's really important to remember the personal and the human dimension of all those with whom we interact. So for all those many reasons, I thought it was a wonderful, important, multifaceted talk, really in the tradition of this important lecture series. So thank you so much for sharing it with us today. And thanks to all who have kept this lecture series so vibrant and so important over the past 20 years now, and keeping the legacy of Sir Bernard Crossland alive in this way. Even for me as an undergraduate many, many years ago in University College Dublin, I was aware of Sir Bernard and his reputation. It was only very recently, looking through the exact details of that reputation, that I realised what an extraordinary figure he was. Fellow of the Royal Society and a former Vice President, Fellow of the Royal Academy of Engineering and winner of their Sustainable Achievement Award, Fellow of the Irish Academy of Engineering, member of the Royal Irish Academy, President of the Institution of Mechanical Engineers, an extraordinary and towering figure. And I think it's so important that we do continue to respect his legacy and to bring his values forward to the next generations of engineers and engineering students. We in Engineers Ireland, and I as President of Engineers Ireland, are absolutely delighted to be associated with this very important series, and I see a number of past presidents here in the audience also. And thanks to all who do work to keep this legacy alive. Thanks to Jonathan and the organising committee. Thanks to Gerard and our northern region who worked very hard on this. Thanks to Queen's University Belfast for the use of this wonderful, wonderful facility here, and for all that you have done to keep this series so important and so vibrant. So, and thanks also to all of you who've joined us here in the room this evening. It's such a pleasure to meet people in person, many familiar faces and old friends, and also newer faces for me. It's really great to be in the room together. Also great that so many of you can join us online. I think we are finding our way to see the best of both worlds, how we can have all the wonderful personal engagement, but also reach the broader audience that your wonderful talk, Iain, so deserved. So I'm now standing between a number of people and their dinner, so maybe in the room and at home. So I have one final and very pleasurable task to perform, and that is to present you with this really, really lovely and very fitting sculpture, the Sir Bernard Crossland cube. And I think it kind of enshrines the engineering ethos and also the beauty of engineering. So thank you once again, Iain. It's been a real pleasure, and here is your memento of a wonderful occasion. Thank you very much. Lovely, isn't it? Yeah, really beautiful. I don't know. You can run that now. Yes, exactly. Yes, yes. So thank you all for joining us, and enjoy your dinner.